My name is Karl Weaver. I'm a wireless market mobile device specialist. I spent my entire professional career focused on selling mobile technologies to the Chinese handset manufacturing ecosystem in Taiwan and China. What I wanted to do is give you, just pass around some of these smart card technologies with NFC. Basically in 2008, I was at a Las Vegas smartphone summit. I've been a normal public speaker on smartphones since the inception, almost since the inception of smartphones. Started my career publicly speaking on smartphones in 2003. Anyway, I was at the Vegas Smartphone Summit. I was giving a presentation on smartphones for mobile WiMAX. There was only one handset vendor, it was HTC. And then a company in the audience called Gemalto approached me and they said, hey, we're interested in a guy who speaks Mandarin because I'm bilingual in Mandarin Chinese, who can go to China and Taiwan and promote near-field communications. At first I said, did you say gelato? Isn't that Italian ice cream? And I said, no, it's Gemalto. And they said, we're the global leader in digital security. I had no clue what NFC was. I'd only seen it once in Hong Kong. And also I didn't know who Gemalto was. It's a French company. It's global leader in digital security. Anybody, maybe you know who Gemalto is. It is a leader. I basically was hired by Gemalto to crack the chicken and egg between handset manufacturers and operators who were fighting with each other. Now it's the operators and the banks, but previously it was the handset vendors wouldn't design NFC handsets. I got that mission to go to China to develop that with China and Taiwan because of my language skills, my ability, and knowledge of the handset manufacturing ecosystem. So 2008, I went there and I realized there was no NFC handset anywhere in Asia. The only feature phone, ugly feature phone, was from Nokia that they were pitching with Visa in 2007. They started in, I guess, Hong Kong. But basically, I had to plead Nokia to give me an ugly feature phone so I could show all the other handset manufacturers what NFC was on a smartphone, because nobody'd seen it. Nobody had seen it before. That was a real tough time trying to work with Nokia. Anyway, well, that's a long story with Nokia. Nokia is one of the 3 co-inventors of NFC, which doesn't stand for Go Seahawks, National Football Conference, doesn't stand for No Functional Clue, doesn't stand not for commerce, but it stands for Near Field Communications. It's really, really important that you all understand this, because guess what? How many people here have an iPhone 6? Whoa, hello. If you don't, it's a little expensive, and I understand. I just got mine. It's right there. Okay, so today's presentation, we'll be talking about device security, the cloud, something called Host Card Emulation. I'll tell you where that baby came from. I'll be talking about near-field communications. I'll be talking about the smart card industry, because guess what? And also the security of these devices and the security of the cloud, because it's all connected. And if you try to give a presentation without discussing all these topics, you miss the point, which is security, security, security. Today's presentation, the growth of Host Card Emulation for mobile, NFC, smartphone payments in the cloud. Damn long title, sorry about that, that's life. Let's go on. Now, if you're in the, who's in the wireless industry here? I don't mean an IT software guy. Who's actually in the wireless industry? Oh my God, come on, some hands. Anybody? Oh boy. All right, so this is the mobile ecosystem complexity as it exists in the wireless space, and there are lots of breach possibilities. The silicon chip vendors, the handset manufacturers, the operating system vendors. But I have my wrath for you operating system vendors, even if you're Microsoft. Oh, stay away from me. No, I'm joking. But how it works is the operators have markets. The operators work with handset manufacturers, right? That's a tool that they use to sell. They sell smartphones, but their tool is actually the SIM card. Why? Tamper resistance. The SIM card is somewhat tamper resistant. I say somewhat because somebody's going to say, no, it's not 100%. No, it isn't, but it's pretty damn close. Smartphones use chips, and they use the operating system. The operating system and chip vendors sell the technologies to the handset vendors, who sell to the operators, who sell to the verticals in the wireless space. Also, value-added service providers and app marketplace, apps developers, and mobile operating system. Well, apps developers make apps for the marketplace, which go to the operators and also into the market. Value-added service providers, they do the same thing through the operators into the market. This is a complex, extremely complex ecosystem to manage the security for. I'm going to go fast. There are 3 routes to the Holy Grail, and I don't mean Indiana Jones. There are 3 routes to the Holy Grail of mobile payments in this world today, but primarily this is the United States. SimplyTapp is a small company that sold their technology in 2012 to Google to provide something called Host Card Emulation. But they weren't the first company to try to do this, to remove the power of the USIM card in the mobile payment handset, because banks and operators don't get along. Lots of people don't get along with operators. Now, Google had something called Google Wallet. They promoted it in 2011. By 2013, the company formerly known as ISIS, right? Not a cute Egyptian lady. No. ISIS is T-Mobile, Verizon, and AT&T. They combined together to form a mobile payment platform based on the USIM card, right? However, they had to change the name in 2014 to Softcard. Softcard is basically on the right side here, and they have a mobile payment platform that's very secure because they use something called the Trusted Service Manager from Gemalto and some other vendors. Now, they base their security, tamper-resistant security on the SIM card. That's how Softcard is doing it. But Softcard may be sold either to Google, to Microsoft, because God damn it, Microsoft have been poor or slow with mobile payments. Sorry to say, anybody here from Microsoft? That's probably a dumb question. and then finally, actually, the company that I think is going to buy Softcard is Apple, and I have my reasons for that. But it's going to be Apple, Google, or Microsoft will buy Softcard. This company has been a failure. All right, now up top here we have the famous Apple Pay on the Apple 6 and 6 Plus, right? Uses Touch ID. It uses the embedded secure element from NXP. Bingo, it just works. Apple makes payment simple. That's why they call it Apple Pay. On the left side here, we have something interesting, though, that's been transpiring. I was in China last week talking to China UnionPay, which is the most powerful company in China, by the way, because they control everything. They control the banks. They're the government. The operators are semi-governmental. They're really the government, all right? So there's something called Android Pay. Has anybody heard of this? Something called Android Pay. Android Pay will use what we call Host Card Emulation from SimplyTapp. Basically, Google has been knocked down so many times, but they keep coming back for more pay. And it's very, very interesting. They keep coming up with new strategies to win. My God, I wish Microsoft could be a little bit more aggressive on this side. So Google will probably buy a mobile network operator. It looks like they're going to try to do that. But they also, I think, want to buy Softcard. Logic, and all this. So we have 3 camps. We have 3 camps. Either will be fine. Doesn't matter what handset you have, you're going to use one of these technologies. Now, you see, I was talking about smart cards. You really can't talk about payment without talking about the SIM card, because that's how payments originally was meant to be set up, using the embedded secure element in the SIM card. Smart cards are quite interesting. I joined Gemalto in 2008. Gemalto invented what formerly known as Gem plus Exalto, merged together in 2006 to form GemMalto. Not really an Italian ice cream. Anyway, so this company basically employed me to promote what we call the USIM, the NFC USIM card, the SWP NFC USIM card. SWP meaning single wire protocol. This is the security between the controller chip, the SIM card, up to the operator's OTA network. This technology, basically, Gemalto doesn't just make SIM cards though. If you look at your credit card right now, you'll find that your credit card is made by one of only 3 manufacturers, either Obertor, another French company, G&D, can't even say the word, it's a German company, or Gemalto, which is a French company. 2 French companies, 1 German company. All your credit cards, all your debit cards are typically made by those guys. They have the best security for chip technology. Now, they follow with contact and contactless something called ISO 7816. And now ISO 7816 means that you have a smart chip in your credit card. And by the way, by October of this year, you better well have it there, because you're going to take the risk, as well as the merchant, is going to take the risk plus you by October of 2015. So you definitely have to make sure that You push your credit card company to make sure you have chip and PIN or chip and signature, which is what's rolling out with Costco. Woo. All right. Contactless, on the other hand, only works in one frequency. I've heard so many people tell me RFID, NFC, it's all the same thing. Absolute BS. It's not the same thing, okay? NFC only works in one frequency, and it's bidirectional too. So it's full duplex. 13.56 megahertz frequency range is what NFC works in. And by the way, the protocol is ISO 14443. All right, so that's where we are with smart cards, which can be credit cards or anything else. If you see the document there, if you see all those smart cards, oh, he's looking at it, great. Now, secure element is a little bit different. It's a tamper-resistant entity within the SIM card, but it doesn't have to be in the SIM card. It can be an embedded controller chip. It can be in a micro SD. Okay, so that's what we have. That's what we call secure elements in smart cards. Smart cards can be made into many different things. Very quickly, NFC phone architecture. It's not really rocket science. You have a controller chip, which uses a single wire protocol connection to the USIM card, and then up to the OTA server, and of course your mobile apps processor chip also operates with the SWV protocol and also HCI. Now, there's an antenna that connects to the controller chip to provide the connectivity. Apple's done a great job when they have lots of IP for NFC. So for 5 years, Apple was basically toying with the whole community until they had all the IP in place, all the patents in place. You cannot beat Apple. They're just so clever. Anyway, how it works is you have a smart OS. All these operating systems have a smart OS. You have various protocols which are historic, actually. They're historic. It's not just, NFC is not just one thing. It's type A, it's type B, it's MyFair. It's a bunch of different protocols all meshed together for the NFC forum. You have to have a mobile wallet. That's your UI interface. You have to have a controller chip and an NFC stack as well. And something called the secure domain, which is inside the secure element. It's basically a storage facility. Let me move on. Contactless NFC. You have NFC smartphones. Did you know that Apple's only using one mode right now? That mode is what? Card emulation. They're emulating a card, right? Did you know there are two other modes? There's peer-to-peer, where you can touch another handset, or you can touch an ATM machine. There's also card read or write mode, where you can put a little tag onto. You can put a tag onto you can put a tag anywhere, but you can also. And you always ask questions. I know you. Just hold on one second. But you can also go up to from coming up to a subway, you can actually touch a smart poster and get the map where you're going. Okay.
The Royal Bank took Mondex apart based on the peer-to-peer financial transactions because of the fact that it wouldn't let it go through the central, banking system. So peer-to-peer in financial transactions, it can be a bit dangerous.
Yes, but I think that what I've seen is lots of ATM vendors.
20 years ago.
Lots of ATM vendors though want to put NFC right at the ATM point of sale, especially in Hong Kong. Hong Kong was really, but that's a good question, I think. Let me move on because I want to get to the crux of what we're talking about here tonight, which is you guys like to talk about the cloud. My God, there's also a lot of hype about the cloud too, but let me bring it down to reality. With this technology, let me bring it down to reality. This is the normal way that an NFC controller, or your point of sale reader at the merchant. It normally goes to the controller to the SIM card. That's how an NFC handset works, Softcard. But this is what Google is using. They're taking the reader and they're using Host Card Emulation with the controller and sending it to the host CPU. So basically you're avoiding using the SIM card. Who does not like that? Softcard, all the MNOs around the world, the GSMA, all of the contactless organizations, they're kind of neutral. So here's the real problem here, which is, where is this all leading? Well, I can tell you where it's leading. Google KitKat 4.4 uses HCE. It does not use the embedded secure element anymore because they failed to make the embedded secure element successful with the operators, including Softcard, who kicked them out. So this is a TSM. Very complicated, very confusing. Basically, it's a third party. TSM means Trusted Service Manager. It's a third party vendor that basically manages your handset when it's lost. Do you think you call the operator and the operator is immediately going to use GPS to find your handset? No, absolutely not. They go through a third party called a trusted service manager. They just haven't told you that. Who is that trusted service manager? Well, Softcard deploys one from Gemalto or G&D. There are a bunch of different TSMs around the world, but they're complicated, damn expensive, and they cut out many vendors, especially the banks. Banks don't like that. This is a bit more complex, but you techie guys are going to love this. So what is this? This explains a typical using an NFC handset with a SIM card, secure element in the SIM card. This is basically how a TSM works. Here's your handset with NFC. This is your this is your software. You have a mobile app, your wallet, you have a secure element inside, and then it uses a TSM from the MNO side. Also, the bank has also a TSM. So you have actually two types of TSMs as you're making the payment in the network at the point of sale. Damn complicated, expensive, but it is very, very secure. It does work. This is how HCE will use the cloud and the environment to make a provision payment from the cloud back down to the handset in the open operating system to make a mobile payment using NFC. This is all using NFC technology. For you people who think barcode is the way to go and it looks sexy, my God, it's old, it's not safe. Forget it, okay? How this works is in the mobile app, a wallet, you have the payment credentials. You have a secure element, but that's only operating for the network. You have an MNO TSM. Look, there's no connection, and you have a bank. Now the bank can have a TSM, but more likely it's going to have what's the term? It is a token service provider, not a trusted service manager. A token service provider, because when it provisions mobile payment data in the cloud, it provisions it and sends it down to the handset as a token, which is much more secure. This is exactly what Apple's doing. Google's doing the same thing. The problem is that it's not secure. It is simply not secure when it comes down to the open operating system smartphone. Hackers are waiting. They can identify and intercept it. But tokens are pretty much data that hackers can't read or can't use or can't have any value to them. Only lasts a short time, 10, 15 minutes. Some would say it's good enough, but actually hackers are much more sophisticated than you think. And anybody here deal with hackers on a daily basis? Yeah? Yes? No? They're pretty sophisticated. Developer platform. So I started to interface in May with this company called SimplyTapp out of Texas, small company in Texas, that actually sold the technology in 2013 to Google. And then I started to work with them because they're interested in perhaps taking this technology directly to the Chinese handset manufacturers. So they actually have a free downloadable app that you can play with at their website, or if you need the support, they'll charge you for that. So if you are an entrepreneurial person and you want to go to a bank and say, hey, I'll make you a nice mobile wallet and you don't have to deal with Softcard, or you don't have to deal with the operators. And by the way, we'll provision it any way you want, and then we can provide the security. Well, be careful when they say they can provide the security, because actually, unless you have tamper resistance for those payment credentials, no, you don't have the security that you think you have on an open operating system smartphone. But basically, this is the developer platform from SimplyTapp. Okay. How to emulate a secure element in the cloud. Oh, it's as you see, you have a secure element in the cloud. It gets provisioned and goes right into the open operating system through an API, right into the open operating system and ready for the NFC controller. And on the other side is what? Your point of sale device, right? So actually, this works. It's being used. Companies are deploying this. There's a company in California called Sequent Software. They've been trying to get this deployed with Sprint. Okay, so Softcard is launched, the three operators, and then what happened to the fourth operator? They were part of Softcard. They migrated to use Sequent Software's technology, which is using HCE. There are banks in Russia that have deployed this technology, banks in Australia. This is leading stuff, and I think Microsoft is going to use this technology as well. That's what I think. So how do you provision? Okay, you have applications user, secure element, going to the handset, as we said before, but originally the credentials were stored in the secure element in a USIM card. By moving the secure element to a remote environment, dependency and costs are removed. You're reducing cost, you're reducing dependency, you're reducing the control from the operator who says, no, you can't do that, you can't do that. Banks love this stuff, actually. With a secure element in the cloud, you can see you can have multiple issuers for the secure element into the device. So it is very, very interesting. I do believe that Microsoft is working to use this technology. Google is using it. Actually, the first inventor of this technology or similar technology was Blackberry, 2007. Sorry, 2007? No, 2011. They call it Virtual Target Emulation. They basically avoided the use of the SIM card for the payment credentials. It's very interesting stuff. Am I going too fast? No, not for your engineers, right? All right, tokenization of EMV payments. Beefing up the security of Host Card Emulation. This is it. Google and Apple are using tokens. But Apple's way to use tokens are very cool, very secure, and seamless, and they simply work. They're using Touch ID. From the Touch ID, the payment credentials are provisioned onto the handset and then to the embedded secure element. The embedded secure element is coming from NXP, a Dutch company that was originally Philips. The three inventors of NFC technology are Philips, Sony, and a little bit from Nokia. These are the three inventors of this technology. But this technology spun out from Gemalto because Gemalto didn't think it was that important. So they spun it out, and the guys left Gemalto and they went to go work at Philips in, I think in France. This is like a year 2000, 2001. That's the history of all this NFC technology. So how do these tokens work? These tokens, as you know, it's not a real credit card number. It's been scrambled to the benefit of you, to the benefit of the merchant, to the benefit of the card issuer who provides the token, right? Visa, MasterCard, Amex. This basically secures that hackers who get the details in the open operating system cannot just use them and hack your number and find your credit card details and off to the bank they are. So tokens are very good, but if they don't have security when they're stored, then hackers can still get to it. So that's why Android Pay, what is Android Pay about? Android Pay is really about taking the payment credentials from the cloud where they're stored and sent down to the open operating system. But actually what happens is you need to put them, if you leave them in the open operating system, I'm sorry, but they're not secure. And no bank will allow that, or at least they'll ask for some other level of security, maybe two-factor authentication, maybe peer-to-peer type of encryption, and I'm not even sure if that will do it. You really need tamper-resistant storage, either in the embedded secure element from NXP or other companies, or where else, guys? Come on, you guys are smart. Where else? Where else can you put a virtual secure element coming from the cloud? Where can you put it? Where else? If you don't put it in the SIM card, where else can you put it? Think about this for a minute. No. You guys, if you put things in the cloud, it's like a fox going into the chicken coop. Where else? Think about this. In the mobile apps processor chip. I'll tell you a little secret. Apple has excellent security. Why? Because what they have told NXP not to tell the world is that they're using something called Trust Zone. Have you ever heard of this thing? Trust Zone. Trust Zone is a firewall environment in the chip. Apple is using it. They just tell NXP, keep quiet. This is how they ensure the security. Guaranteed this is what's going on with Apple Pay. Back to the emergence of tokens for mobile NFC payment smartphones. I think you're going to see tokens. I think you're going to see Microsoft use tokens. Google is using tokens. Apple is using tokens. Any other? Okay, maybe Blackberry. Blackberry, I'm a steady believer that Blackberry is not dead. Knock on wood. I'm a steady believer that this company will come back because they've got good products and good technology. Let me move forward. I'm just going to give you a comparison between how Apple does tokens, and you can see the chart here, and just how simple it is with using SimplyTapp and a tokenized permanent secure element. It's just so much easier, but hey, you know, Apple is Apple. Apple's going to do what Apple wants, and Apple Apple has done something very smart. They have not ticked off the banks. They have not ticked off the mobile network operators too much. And they've said, well, basically, let freedom reign. The banks are still operating. They're happy. The credit card companies are happy for sure. The MNOs are selling Android. They're selling Apple handsets, and they're making money, right? Everyone is happy with this solution. Google's solution makes people unhappy. However, Android OS is 70% of the whole damn world. So you have no choice. You have no choice because you didn't want to spend $900 for your iPhone 6 or 6 Plus. You're going to buy an Android smartphone.
Well, you're talking about a high-end device here, first of all. I mean, you keep talking about the iPhone and the fact that, full disclosure, I work for Microsoft.
Oh, good for you.
Well, but let me say that it's a very expensive device. So, you know, you think about the market, there's a lot of folks out there that are going to purchase the device. Why does Android have huge market share? Because they have devices at a full range. What's the biggest security risk of an Android device? It's an open environment. Anybody can open it up. I mean, I think you got a couple of things here you're kind of mashing together, too.
I have to. I have very little time, and I have lots of technology topics to mesh. But in defense of all this, you're right. In defense of all this, you can find smartphones with NFC for about $300, all the way up to about $600. That's the range for an NFC handset, because NXP charges a lot for that NFC chip. They're selling it to Apple very cheaply, but all the other guys buy small volume and they can't afford
But
it.
if the stack on top of the chip is not secure, it doesn't matter how great of a chip you have. The chipset is only a piece of this. It comes back to the whole core concept that an Android environment today is still extremely exposable.
Yes! Absolutely correct. Therefore, have you heard of the trusted execution environment? Okay, this is something that ARM cooperated. With Trusted Logic that Gemalto bought in 2010 to provide a security operating system in the firewall of the chip to provide sensitive applications a place where hackers can't get to it, because it's software combined with hardware security. This is what ARM is doing with every single major chip vendor on the planet, already implemented, already being used for one use case, which is high-definition streaming video content for Netflix, Google Prime, Amazon. They're all using this technology right now, the TEE, Trusted Execution Environment. You can look it up. But they want to push it to promote mobile payment credentials. And that's a little bit more tricky because, well, it's expensive, it's not cheap. You know security is not cheap. The return on investment for security is only after you've been breached for most people, because it's damn expensive for security on a mobile device. Smartphone, tablet, smart TV, set-top box, etc., 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 etc. They all use the mobile apps processor chip. So ARM and Trusted Logic provide this highest level of security that available on the planet. I believe that payment credentials are going to go into the mobile apps processor chip, and they are. That's it. In 2010, this is what HTC told me that they wanted to do, because I was promoting this technology to all the handset manufacturers in Taiwan and China. So you're right about everything you've said, but the reality is Android is still 70% of the market, and I think iPhone is about, what, 20+% of the market, something like that. And the other 10% are split between Microsoft and I think Blackberry. That's pretty much the market. Would you agree?
Numbers are changing. Last time I heard that, I wouldn't say I disagree.
Okay. Would you agree that the way Apple has done it is still pretty damn cool? The way they've provided it a seamless KISS principle. A lot of people talk about the KISS principle. It's very difficult to implement the KISS principle. Apple has done it. They've been investing in IP for NFC and for payment for at least 5-6 years. They just didn't tell anybody. But if you go on Patently Apple, you can see all the apps. They've been registered. Now, I want to talk about Android Pay a bit. Android Pay is being developed by China UnionPay. Why? They have 70% of the whole market. Why? Because all the handsets in the world are made either in Taiwan or China. Nobody else makes handsets. We don't make handsets in America, although Motorola was taking them in from Mexico into Texas to manufacture, to have that Made in America logo, right? But the fact is they were all coming from China. Google sold Motorola Mobility. They sold it to who? Lenovo, very, very recently. So that means that there's only one major U.S. handset manufacturer operating in the key manufacturing ecosystem, which is China and Taiwan. Only one, that's Apple. Yes, Apple is smart, and they control all the ecosystem. They're very smart. Samsung, they're a South Korean company, pretty strong in the United States, but they're losing market share to the Chinese. The Chinese are taking over the handset manufacturing ecosystem. So if you're going to sell technology, you better know the Chinese handset manufacturers, because pretty much they control at least 50% of the whole, market now for manufacturing. And I don't even include HTC, which is a very strong Microsoft partner. I don't even include HTC as being Chinese because, well, they're technically Taiwan. But how does Android, you don't agree? Okay, well, too bad. UnionPay has announced a partnership with Apple for Apple Pay. That will take place after the Chinese New Year, which is February 19th. After that, though, by Q3 of this year, Android Pay will launch. Why? Because actually UnionPay is not necessarily competing with Apple, but UnionPay is a Chinese state-owned enterprise. So they want to help local Chinese handset manufacturers, of which most of them use Android operating system. So yes, they'll cooperate with Apple Pay, but they're competing with Apple Pay. Now, who's competing with China UnionPay? They just put an office right next to Amazon. Alibaba. Alibaba. Whoa, good for you. Alibaba was closed out of the Chinese market for barcode payments. Okay, why? Because China UnionPay said, hey, these guys have too high of a market share. So, state-owned enterprise, China UnionPay. That's why Alibaba and maybe Alipay are coming to the United States, because they want to continue to use barcode, which, okay, but they're also experimenting with NFC technology. So Android Pay is really about China UnionPay working with handset manufacturers, right? These handset manufacturers are going to use the Android operating system and Host Card Emulation to provide mobile payments. However, the issue still exists with security. As you said, the issue is still security. I believe you have two and only two choices there. Embedded secure element from NXP or this TEE, Trusted Execution Environment. I'm the guy who sold it to China UnionPay, so I know that that's what they're looking at using. However, I also worked with NXP, and I know NXP would love to deal with all the Chinese handset makers to sell more chips. They're doing well with Apple, but they still want to capture the other market, which is also huge for them. So that's what Android Pay is about. All right. EMV versus cloud-based payment cryptograms. Cryptograms work differently with the EMV. By the way, does anybody know what does everybody know what EMV is? Europay, Visa, MasterCard? Your credit card complies with this standard, but it isn't just the credit card or debit card. It's your smartphone. Your smartphone must comply with this technology as well. So your smartphone and your credit card. Now, who is Visa's biggest competitor in the world? Who is Visa's biggest competitor in the world?
China UnionPay.
Bingo.
So all these solutions, they only apply to point-of-sale transactions, not to online, right?
Okay, so let's move back one step. We have two types of payment on a smartphone. We have remote payment using a browser, going on the browser using your credit card and possibly a wallet, and you're making a mobile payment remotely. We call that remote payment. You also have proximity payment, which uses NFC, barcode, Bluetooth, etc., etc. So there are two types of mobile payment that we're talking about pretty much in the world today that I know of. So,
and so all this applies only to the proximity, is that right?
I'm not sure. I am not sure. But I do know one thing. I do know that that Alibaba will not work with China UnionPay because they're enemies, because Alibaba has 80% of the proximity market in China using barcode or previous barcode, and they've started to use NFC. But the 20% of the market, or almost maybe 30 now, is China UnionPay and the operators, and they're not happy with Alibaba. Okay, so you won't see them working together too soon. In fact, Android Pay is a play by China UnionPay to compete with Alibaba. That's what it is. That's very interesting. Well, the other interesting thing is Alibaba could do the same thing with all the handset manufacturers. So it's really, really very, very interesting. This is just talking about the EMV versus cloud-based cryptograms that go from the cloud onto the handset and onto the terminal. much too complex. I want to move on, if you don't mind. MCX, does anybody know who MCX is? This is called client merchant exchange or something like that. This is basically companies like Best Buy, Walmart. They basically said when Apple iPhone 6 came out, they said, oh no, you can't use NFC on our point of sale devices. Oh no, we don't want to do that. Actually, the thing is NFC is here to stay. It's not going away. It's going to become more and more prevalent. Your Orca card uses NFC, and more applications are coming to the state. I really wish this state would be more active with this technology. I really wish Microsoft would go up to the Orca Sound Transit people and say, hey, we'll make an app for you. We want it on our Windows phones. Hey, we'll make an app and let's put it on Windows phones. Maybe that's what you're doing now. Anybody here at Microsoft? Maybe that, if you're not doing it, you should be doing it, in my humble opinion.
Free advice.
All right, all right, we have Apple Pay, and it's working with Visa, MasterCard, and Amex, and it uses NFC technology, and it uses Touch ID. It's seamless, and these are all the customers, but there are actually a lot of customers with this technology is barcode. It's barcode. It's barcode. It's old. You can't use it for many things, but it does work, and it's free, generally speaking. These are the merchants working with Apple. These guys are in the middle, they're working with both, and these are non-Apple. You know what? Some of these guys have migrated already over. Apple Pay has opened the floodgates, essentially. Now, I'm sorry, now we're going to get to real security for hardware, okay? Probably been waiting for this. All right, I'm here to bust your bubble. First of all, I don't believe there's enough security in the cloud. So, sorry, that's how I feel, because I come from the Gemalto world. And so that's what I think. I think that hackers are very sophisticated. The same guys that you're training are the guys who are becoming the world's leading hackers in the world. The same people that we're training are becoming the biggest hackers in the world, from all over the world, and I will be controversial here. The largest hacking country in the world is China. Number 2 is Russia. Number 3, I wonder, maybe the NSA. I don't know. But I'm happy that the NSA has good technology, because I would prefer to feel safe when I go to bed at night that the NSA knows how to infiltrate some of the dark elements of the world. That's all I want to say. Enough for that. Any reporters in the room? Okay, go report that. Software-only solutions at the OS level. You cannot stop malware in the open operating system of a smartphone or a tablet, smart TV, connected car. Okay, Houston, we really have a damn problem. We have no way to stop hackers from infiltrating the open operating system of any operating system. No way. Not in the open operating system. Now, hackers are very sophisticated. However, I just mentioned this TEE to you, and I mentioned ARM. If you were watching the news lately, ARM came out and said, you know what, we're not only providing security called the Trust Zone to the smartphones and tablets, hey, we're going to provide it for the Internet of Things. Bingo. So the future of connected devices equals ARM. Yes, it also equals Intel, but Intel is only 10% of the market. Intel is doing something very similar to ARM with this TEE technology, basically.
You can actually lock the OS with TPM type trusted boot technologies.
Didn't hear you.
You can lock the OS level with TPM class trusted boot technologies where you're assigning and validating.
If I have layer 4, I can do anything, but that's the government. So, okay, hold on to your questions to the end. OS itself has flaws. Handset firmware in OS can be modified. Hardware attacks require to be countered with hardware protection. It's actually software plus hardware. I knew this crowd would be tough. I'm tougher. Mobile OS cannot be verified and certified in security. You need to minimize the risk. Isolation, guys and girls, that's what we're talking about here. Isolation into an embedded secure element environment, well, an embedded environment called the TEE, the Trusted Execution Environment in Trust Zone. Hey, I didn't make this stuff up. Go do your research. Look at this stuff. Why is all this stuff happening? Because third-party app stores can take legitimate code, download it, put all kinds of fancy malware into it, upload it to the same store or a different store, you download it, bingo. You have 007. Okay? You have people spying on you. You have people who can listen to your voicemail, listen to your camera, watch your camera. Hey, you have no damn security. you actually have no security now. You probably just don't know it, or you don't have any money, so they don't want to steal from you. Trust me, when you have money, they want to steal. That's what they want to steal. And they also want to steal other things like MP3s, MP4s. Hey, the reality is people want to steal things from you from your smartphone. Let me go on. Malware, you know what it is? Malicious code. Code that can be implemented onto any operating system that can be uploaded to any device. Now, this is pretty damn scary. Even the logo there is scary. Look at that. Ooh. You have SMS, premium SMS messages. You get a message. Hey, Johnny, open up this email. You don't even know who the hell Johnny is. You've got problems like that. You have adware. You have adware where, my goodness, they provide all these advertisements on your open operating system tablet, desktop, smartphone, and well, I mean, it pretty much gives you, it's annoying, isn't it? It gets on there. Stealing information. Yes, people want to steal information. They use spyware. There's lots of bank fraud. I don't have to tell you about Target. I don't have to tell you about all these breaches. Ransomware. Oh, that's even more interesting. They call you up from, I'm sorry, India, most recently, India. They call you up and they say, we're Microsoft certified software organization. We want to remove all the malware from your PC. Let us get access. You remotely downloaded something that gives you, lets them take control, and they put even more malware into your device. And then when you power it down, power it back up, it's asking for a password. What password? I don't have any password when you open up the device. So this is a problem, ransomware. And then they say, well, only for $5,000, I'll open up your device again. Bingo. Huge problem, guys. If it hasn't happened to you, think about this. Your kids go on and they listen to all kinds of things and they're susceptible. Now, you have also botnets and spam. Spam, we all know about it, goes into your spam folder. Thank goodness. Don't open it. So you've got real problems here, really, real problems. And listen, guys, I'm not going to sugarcoat anything. I'm not an engineer, thank the Lord, but I think I have problems with your engineers who don't tell the world the problems of hardware and software. I mean, you guys were responsible for telling the world about these breaches long, long ago, but you didn't do it. Why? Because, well, your companies told you, keep quiet. I'm here to tell you, you can't keep quiet anymore because the world knows that these devices have no or limited security. I am here to tell you there's a positive way to solve these problems with software and hardware, especially for payment. We only care about security for things like payment. We don't care who listens. I mean, we might not care who listens to or who's looking at our handset. We don't have that much that's secure, but we might. The key point is these are ways that attacks occur. They occur with sensitive data through communications ports in the open operating system. Malware gets into sensitive data. It exploits these communications protocols. SMS, text messaging, Bluetooth. These aren't Wi-Fi. These are not secure. Come on. Hardware attacks. So that's software, but hardware attacks. They can actually get to the flash. They can get to the SRAM. They can get to the JPEG, which you use for communication purposes with a mobile app processor chip. This is how sophisticated hackers are. Let me move on. This thing called the TEE is called the Trusted Execution Environment, part of Trusted Computing Group, right? And basically, I have a suspicion that Apple is working with IBM specifically to use this technology or similar technology to provide trusted computing apps, financial, sensitive stuff that they can provide in an online store with security. And that's why I believe Apple is working with IBM, I believe. Well, but they both need each other, don't they? But I think this has something to do with it. So, as I said, this technology, you have rich applications. You've got a rich OS, but you need APIs from Global Platform. By the way, that's the organization that standardizes the secure element and the TEE. You have these apps, these APIs that go into this secured firewall environment and provide the security that you need. Again, there are two major use cases. Well, actually three. VPNs, number one. High definition video content protection, number two. And mobile wallet PIN codes or mobile wallet credentials. These are the things, these use cases for the TEE. We go on. Trust Zone and Trustonic. Trustonic is the spin-out from Trusted Logic. Jamal told about Trusted Logic 2010. I was already the NFC rainmaker for the Chinese world. They made me the TEE guy. I didn't know anything about the TEE, but they made me the TEE guy to promote that. In 2013, they spun out ARM 40% of this JV called Trustonic, strange bedfellows, right? Trustonic, Gemalto, and a company called G&D, the other smart card vendor. These three companies are in it for the long haul to provide you embedded mobile device security based on security OS plus the firewall environment in the mobile apps processor chip of ARM core chips, ARM 11 and above. But they're basically, who is it sold to? System on chip manufacturers, silicon chip vendors, and device OEMs. Now this is software attacks countered with TE. So basically, I don't work for these organizations anymore, so I'm not endorsing them, but I'm just telling you this technology exists. This is basically software logical attacks and hardware logical attacks which have been solved. And hardware attacks countered with the TE-based security. So, I mean, you're welcome to these slides. This is important stuff as well, by the way. Trust on it, I used to say, is trust on the IC. Here's the big ball game. SIM cards are going away as removable devices. Why? Storage, not enough. Power, not enough. Everything is going into a chip, especially the mobile apps processor chip. So, Microsoft, buy a chip company, in my humble opinion. Buy a chip company. Use this technology. There are multiple use cases. Smartphones, tablets, smart TVs, Internet of Things, etc., etc., etc. So these are the use cases for the TEE. I wanted to say something about, do we have a minute more? I mean, I have the crowd here. I have them at my mercy. Cryptocurrencies. I wanted to say something about cryptocurrencies because I was pretty ignorant about cryptocurrencies. I knew nothing about them. Cryptocurrencies, where's the Microsoft guy? Tell me about cryptocurrencies. Ah, come on. Cough it up. You know that BitPay is working with Microsoft, right? For cryptocurrencies. Maybe Mr. Bill Gates' version of telling the world, well, cryptocurrencies are the world, are the future. I don't know. I don't know either. I don't know what Microsoft's doing. I'm still trying to figure it out. But cryptocurrencies have a place in the world in the future. Only if they can be tamper resistant. I've said it more than once. If cryptocurrencies use NFC technology and they're stored in some kind of tamper resistant SIM card, embedded secure element, my goodness, whoa, bankers, watch out, because cryptocurrencies are very interesting technology. I think they're going to have validity in the future, although lots of governments want to tax them, lots of banks and lots of countries want to ban them. I think that's pretty illegitimate because cryptocurrencies are the future, I believe. Almost to the end here. Oh my goodness, look at this damn long conclusion. I can read it, but I think what I'll do right now is, we're over time. Look at, you haven't run out the door. Fantastic. I'm sure you have lots of questions. I'm sure you want to beat me up. No problem. I have a very thick face. So who has questions? Who has questions? I'll pretty much answer all of them. Oh, Mark!
So I got a question, Carl.
Yes, sir.
So it sounds like you've talked about different approaches to mobile payments.
Yes.
I'm guessing over time, at least we've seen this, that over time they're going to, do you think they're going to coalesce into one approach?
This is a good question.
15 years from now?
Oh, no.
Or faster than that?
Well, actually, if you look at Android Pay, actually, the only way that a handset manufacturer can sell a smartphone is to an operator, pretty much. Except for small cases like a #1 company in China called Xiaomi. Yeah. They're not dealing with any operator. But I think the future...
Blue doesn't sell to operators either.
Don't know them, but we'll talk later. So here's what I think. When you sell a smartphone, you can't just sell it to one operator. You have to sell it to the world. I believe that right now, hybrid devices are going to emerge where HCE can be used and developed with an SDK, and the SWP NFC SIM card must be the standard for all these smartphones when they develop them. Because what is the SWP NFC SIM card? Not only is it from Gemalto, it's being pushed by everybody, including the GSMA, who, by the way, controls the whole wireless, regulates the whole wireless industry. So yes, absolutely, hybrid phones are here now, and they have to be here now because handset manufacturers have to sell to everybody. They can't just sell to Apple. Well, Apple is a handset manufacturer themselves. They're a special case. Everybody else is in a different ballgame. There will be hybrid devices that allow for multiple technologies and multiple security on those devices. Absolutely.
So you think there'll be, instead of there'll be one standard in 10 years, there'll be multiple standards?
Well, right now, it's not 10 years. It's already here because the SWP NFC SIM card is a standard. HCE is not necessarily a standard. It's just a technology that works with the operating system. But SWP NFC SIM cards, these are standard for all smartphones. Every smartphone except Apple uses the SWP NFC SIM card right now. But they can use HCE as well. So that is already the case right now. Come on, guys, don't be shy.
Well,
Yes,
how do
sir.
we copy your charts?
Yeah, you can, absolutely. There's no secrets here. I'm not the NSA.
You're gonna put them up on the website?
Absolutely, you can. I'll give them to you.
So from a forensics point of view,
Oh,
what about the transaction data and the volatility of that information and how it's stored? So for recourse.
yeah. So this is a very good question because when you have it stored in the cloud, it's provisioned in the cloud and then sent down as a token into the open operating system, at least for Android Pay, right? Excuse me? Yes, yes. But because, by the way, Apple has their own token service provider. And Apple works with the 3 credit card companies. And Apple controls the entire ecosystem. It is closed, but Android is open. And I have suspicions myself that there's not nearly enough security on this technology. So absolutely, there will be problems with, even from the forensic standpoint, of these payment credentials. Because you say tokens are secure. You know what? Who makes tokens? There's some guy who could be working for a token service provider, and he becomes a hacker. I know you guys are not going to like this statement here, but the fact is, you have the responsibility, if you are software developers in this room, to do something better to make sure that these connected devices are more secure. You have the responsibility. And you can't just back down and say, well, it's not my job. Actually, if you're a software engineer, everything I've talked to you tonight, you already know, or you should know. None of this is rocket science. But the real key here is that there probably does need to be a United Nations of norms for software developers, because guess what? Guess what? You can make more money selling malicious code and malicious applications than you can selling drugs. Houston, we really have a problem.
Carl, I have a question. Can you either summarize verbally or send one of us an email of all the things you want Microsoft to do?
Oh.
I forgot how many companies we're supposed to buy. But I do want the list.
Microsoft is a good company, but sometimes the big dragon needs to wake up and smell their coffee.
Mix a metaphor.
Yes, I'll be happy to do that.
I think we got all the surveys. We got all the surveys.
Thank you.